I will talk about the source code of while data transformation program. When we entering a program, it will code out a sentence that lets the user to choose their while data transformation, which is WD for while to data and DW for delta to while. And when their input is key in, it will lead the function to the user defined function, which is named my function 1. And when the input they get from the user in the my function 1, it will let the command, the C++ statement lead to other function, which is while to data and delta to y, according to their inputs. And if they are input E, and it will code out a sentence which confine whether they are going to exit the program or no. If the program is no exit, then the loop will go back to the integer main function and let the program looping again. If the user choose WD and entering a WD in the input, it will lead the program to go to the function while to delta, and it will need the user to key in 3 resistor value that he want to calculate, and the function will automatically calculate the value of the I, RB, and RC that the user input, and it will show the new value of resistor of the while to data. It is same for the delta to while. When the user, it will also need the user to input 3 value of the resistor of delta function, and then it will automatically calculate the value and show the new value of the resistor. And the last function is the final function, the user defined function that named final. It is a function to end the program when if the user press E in the beginning of in the main function, and it will cause the program to exit and return to the 0. If the user input N, which is no, it will back to the integer main function. And the last function is the integer ending, which means the function of the program to exit.
So the values of the R1, R2, R3 and RA, RB, RC is given, which is R1 is 5 ohm, R2 is 7.5 ohm, and R3 is 3 ohm, and as well as RA under 40 ohm, RB is 70 ohm, and RC is 35 ohm. So basically we need to use this table for the testing. So this is the table I have used for the testing purpose. So this is the coding we have developed for our project. First of all, we need to copy this coding, and then we need to paste back in the stimulation. So I'm using code block for the stimulation, and then I just paste, and then after we paste, we need to run the stimulation. So after we run the stimulation, then this one we need to put the required information. So here we can see the statement is please select a Y delta transformation. So press WD, the capital letter WD for Y to delta transformation, and then press DW for delta to Y calculation, and press E to the exit of the program. So we need to use the table given, the information in the table. So first of all, we use for invalid selection. So for this program, for our project, I have chosen the invalid selection as F and N. So F and N, and then the output will be invalid input. So the message displayed yes, and then exit the program no. So we need to continue the program. So for the next, I use WD, which is a Y to delta transformation. So WD, and then we can see here, please type value of the resistor. So for R1 the value is 5 ohm, and then for R2 is 7.5 ohm, and then for R3 is 3 ohm, and then we can see the new value of the resistor is for RA, RB, RC is RA 15 ohm, RB is 10 ohm, and RC is 25 ohm. And then next, we need to choose another what you call input. So for example, I use WD. For this one is W is in capital letter and D is a small letter. So WD, and see the output of the program. So still the same as the WD for the capital letter. So R1 is same 5 ohm, R2 is 7.5 and R3 is 3 ohm, and then the result will be the same for RA, RB, RC. RA is 15, RB is 10 ohm, RC is 25 ohm. And then we need to run the stimulation again. We continue the program for DW is delta to Y transformation. So delta to Y W, and then press DW and then enter. We need to input the value of the RA is given in the table is 140, so 140 ohm, and then RB is 70 ohm and RC is 35 ohm. So the new value of the resistor of R1, R2, R3 is R1 is 10 ohm, R2 is 20 ohm, R3 is 40 ohm. And then we do the same thing for small letter DW, and then we re-enter the values 140 ohm, and then 70 ohm, then 35 ohm. So the value will be the same as the what you call Y to delta for WD capital letter. And then finally we can exit the program. We need to press E for the exit. So let's see what is the output. Press E and then capital letter, and then it will ask, are you sure to exit the program? Yes for Y and capital N for no. So we need to exit the program, so we press Y capital letter and the program will end. And this is the testing result for our program. So basically we use the small letter of WD because here they stated the requirement: allow the access selection input in lowercase or combinational case to perform suitable action. For example, the program is able to execute conversion Y to delta if the user enter small letter WD and then lowercase, or WD. For W is capital letter or D capital letter. So that's why the selection is able to detect any invalid selection, inform the user about it, and receive new input to replace the invalid input. So that's why we use the small letters, the combination of the small letters for the what we call for the result. So that's it from me. Thank you.
Table for input value, and then that's the second input value. Okay, so this verification is about while data transformation. The information we can know, transformation is a technique to reduce common resistor connection between series and parallel. So how we get the data from input voltage, input value? Okay, we get the data from this test data and result. So WD stand for while data, so we get from here, and then we just took in here. So that's our formula to while to delta. So they have two types, conversion, while to delta and delta to y. So we just follow the formula given, while to delta RA RB, RC. And then for this delta to y, there's R1, R2, R3. So how to get the data for delta to y? Okay, we get data from here. Okay, RB, the value is 70, and then RC is 35, and then RA is 140. So as we can see, RB 70, RC 35 is the same value from this data.